Yeah, it's your boy Chili here. Welcome back to C++ Game Engine Infrastructure. Today we are going to be adding stack trace functionality to our code base. Now, take a look at this picture here. We got a function. It's called putPixel, and it draws a pixel on the screen. So it takes in, coordinates and a color. And one of the things it does before it tries to draw that pixel is it checks to see if the coordinates are within the screen region. So obviously if x is less than 0, that's going to be bad. If x is greater than the width of the screen, that's going to be bad. And when it fails one of these checks, it tells you, hey, there was a problem in putPixel. So you get this error message, something went wrong with putPixel. But of course, the problem isn't with putPixel. The problem is with one of the functions that fed into putPixel and gave it some bad arguments. So you have to go up the chain and see, okay, the guy who called putPixel, what is he doing? What's the dog doing? And that doesn't seem too bad, except that in general, it's not going to be just a single chain like this. It's going to be like a whole graph tree kind of deal. And so you don't know exactly who called putPixel. You only know that there was a problem in putPixel. So what you actually want is when this error occurs, you want to know who called putPixel, who called him, all the way up to the entry point. And that is what a stack trace is going to give us. Now we are going to be using a library called backwardCpp for our stack tracing purposes. The beautiful selling point is it's a header only library. You drop in a single header and you're good to go. And another cool thing about it that I like is it can actually, when you print out the stack trace, it prints it nicely with all the source file names, the lines, and even can include source code snippets in your stack trace. And that is very neat. So we will be using it. So here's the header, that's the only one that you really need, and I just go to the raw, and I can save that into my chill solution. I want to put that in the core, but I don't want to put it in the source folder because that's where my source code goes. So for third-party stuff that I'm just kind of manually copying into my project, I'm going to create a folder called third. I'm going to put it in here. There you go. It's in there. So now, what do we do? Well, first of all, we look into here. If I refresh this, I should see third pop up. This is not included in project. Let's include it. It's just a header, so we need to include it somewhere if we want to have it actually build into the system and do something. So we're probably going to want to put a stack trace into our entry here, and that gets forwarded to a channel driver and printing the stack trace at that point. Now, here's the little thing. Here's the thing. Backwards.hpp is a very big boy. It's a very big header file. And if I include this in entry.h so that I can include a stack trace here, that means that that'll get included in entry builder. An entry builder is going to be included in basically every file that does logging, which is going to be most of the files. So we're going to be including backward.hpp in most of the files. That is going to increase the compile time significantly. So I don't want to include backwards.hpp everywhere. How do I get around that? First, let's create a new folder. We're going to call this one UTL. This is utility folder. This is the folder where I basically throw everything into that's not really part of any other major system. It's just a bunch of like support types and support functions. And it's going to get big, but this is, I don't know, I don't have really a better way of doing things. So we're going to add a new item. We're going to call this one stack trace. So we're going to create our own little wrapper around backward, and that is going to do some good work for us. So set up our namespace, chill util, and we are also going to forward declare something in the namespace backward. So we're going to forward declare class stack trace because that's what we want to use, but we don't want to pollute all of our other source files by including backward.hpp everywhere. So we're going to forward declare it here, which means we have to do a pimple idiom, pointer to implementation. So we're going to do that with, I guess we'll use a smart pointer. We'll try it with a smart pointer. Include memory. And we're going to do class stack trace. same name as this one here, but because they're in separate namespaces, it's fine. No problem. Public, private. So the only thing that we want for private is we need a std. Try unique pointer to backward stack trace. P trace. Okay. So that's our pointer to the implementation. Now for our stack trace wrapper, I am going to supply some functions here. I want to print functions so I can print the stack trace, and I also want to be able to copy a stack trace, but since this is a unique pointer, it can't be copied natively by default. We have to supply our own copy for that. So that is that. Now, I'm going to add a CPP file here, and we're going to include backward.hpp. So this is the only place where it'll get compiled, and yeah, that's what we're aiming for. So now we got to start implementing all these functions. So let's just create the definitions. So the constructor is simple enough. We create the stack trace, and then we also want to capture it. So p trace pointer to load here. Let's say it can do maximum 64 frames. Now there's a little trick with backward that you may not know. You probably don't know. You learn it from experience, but there's an issue, an open issue with it. And let's just check this out here. Basically, it fails to load symbols on the first attempt on Windows. So the first time you try to do a stack trace, it is going to give you just no information on the symbols. But if you create an unused instance of something called trace resolver before you do your stack trace, then it works fine. So you just gotta like make one of these unused boys and just put it in here before you do your stack trace, and then everything works fine. It's a little bit of a workaround, it's a little bit of a hack, but it gets the job done. The copy constructor is simple enough. We just gotta make, and we just pass it a reference to the trace we already have, and it will make a copy of that. No issue there. Copy assignment, very similar. The destructor is just here so that, I explained this before, right? So that we generate the destructor in the place where we actually have the definition of backwards.hpp, not in the header. And print. So print is a little more interesting. So the backward library has a built-in printer class. And you do printer.print, and it takes in a stack trace, which would be p trace, and it takes in a stream to print to, which we don't have. Let me see here. I think these are all narrow. Right. Okay, so we need to convert narrow characters to wide characters because we're going to return this as a wide. Let's include stream. And we will do std o stream output string stream. Put the output string here. And now we just have to convert that to wide and return it as a string. So what I'm going to do in our utility namespace here, we are going to add a string header. Going to add some functions to convert from narrow to wide and vice versa. So here's the definition of those functions. I just copied it in from code that I use all the time. And let's take a look at toNarrow. Converts a wide string to a narrow string. Now a wide string is 2 bytes for every character. And a narrow string is variable amount of bytes per character. So for the simple characters like R, O, you're going to do 1 byte per character that appears on the screen. But for like Japanese characters and stuff like that, you will have multiple bytes, 2 or maybe 3 bytes for the character. So what you need to do is, because a single element of a W string might convert into, let's say, 2 elements in a std string, we actually have to make this one bigger. In general, std string is not going to be twice as much because, like I said, a single element like R or O will convert to a single element in std string. But to be safe, we double it. We double the size. Then we call this function. This converts a wide character string to a multi-byte string. We'll give it a pointer to the narrow data to fill, how much size it has available, a pointer to the wide string to use as a source, and it will fill this size t with the actual number of bytes filled, because it might very well be smaller than the total size of the narrow string that we provided, the buffer we provided. And truncate here says if for some, reason the converted size was actually larger than this, it's just going to truncate it at the end. It's going to truncate that string, so you'll lose the tail part of it. And this is a safe function, so this prevents buffer overruns from happening. And I suppose technically it might even be possible that this could overrun, because I think some wide strings might convert to 3 bytes or even 4 bytes, and that would override it. But in general, it's never going to get that big, so I don't know. I just put S times 2. It's never caused me a problem, but I suppose technically it might cause a problem somewhere. So you might want to increase this if you ever see a problem, or if you just feel nervous about it, but I don't. So I'm leaving it as 2. And this one is, the same thing, but in the opposite direction. So we're not doubling the size here because we're going from a narrow to a wide string. So in general, it's going to be, maybe like 2 or 3 might convert to 1 wide character. So in general, this is fine. We do the conversion, we get the actual. And once you've done, I didn't talk about that here, but once you've actually done the conversion, you use the actual number of bytes pushed in to resize this thing. And I guess actual contains the null terminator, and that's why I do resize actual -1. But in any case, this gets you what you need. We can convert wide to narrow, we can convert narrow to wide, and Bob's your uncle. So let's include string.h in here, and let us return utl to wide oss.string. So that'll convert this narrow string into a wide string. We get our stack trace as a W string. And there you go. So there's our stack trace wrapper all done up. I think that's okay. I don't think we need to implement the move operations. It'll just use the default. I could be wrong though. I'm wrong about this stuff sometimes, it happens. So now in entry, we can include stack trace there. And then we can do utl stack trace. And I'm going to make this stack trace optional because we don't want to be stack tracing every single entry. And we probably also want to control the timing of when we generate the trace. So we'll do a optional utl trace. There we go. Okay. Now, when do we actually generate the stack trace? I got some ideas on this. I probably want to configure it a little more. But to begin with, we'll keep it simple. And we will do it in the destructor. So if we have a destination, pdes submit this. So before this, we're going to check to see what our level is. What is our log level? So if int level is less than or equal to error, so if we are error or fatal, we are going to print a stack trace. We just do trace dot in place, and that'll have a stack trace created. All right. So now to actually get the stack trace printed, we have to make our text formatter output it. So what I'm going to do here, because sometimes we can have a trace and sometimes we don't. We have now a condition here. So we're going to put string stream into here. And we're going to go std wide output string stream. So now I'm just thinking, where do we want to put the trace? I guess we'll just put it at the end. So we'll output std format into this string stream like this. And then if e.trace, we should change this entry. This should be an underscore. So if we have a trace, then we'll just do OSS output e.trace pointer to print and std and l. There we go. And then we will return OSS.string. Beautiful. Okay. Now, let's see what this looks like. Let's see if it works, first of all, if it compiles. And then in our sandbox here, I believe we have a fatal and we have a warning. And we have an error. So these two should have stack traces attached to them when we run them. Let's see if it builds. Very well may not. Error. Get env. This function or variable might be unsafe. Consider using dupe env. Okay, annoying. So we have this compiler setting, or maybe I don't think maybe it's static analysis. I don't know, but it's saying that we're using unsafe functions. Now this is in backwards.hpp. This is not our code. So we could start changing their code, and that might be fine. We've copied it in anyways. We can basically fork it. But I'm annoyed. I don't want to do that. So what I'm going to do instead is the thing that I tend to do in cases like this. So what we're going to do is we're going to include, or we're going to define CRT secure no warnings just for this file here. We'll do that at the very beginning. All right, so after we fix that error, we now have a bunch of warnings here, probably static analysis stuff. And what I'm going to do for that, this is third-party stuff, so I don't really want to start monkeying around with it. At least I want to monkey around with it as little as possible. So what I have here is these are the warnings you need to disable. I just have this from another project that uses the same code. So now if I do my normal thing of wrapping the third-party include with a little bit of pragma, we get a nice, clean build, and Bob is your uncle. So now we go into here, and when I look at my output here, you see I've got my stack trace. So get current thread, load here, construct in place, blah, blah, bitty, blah, 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 bitty, blah, 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 bitty, blah. And here is where I actually generate. So this is the place where I'm generating the log. So we see here at the bottom here, we get some kind of like noise because before I generate the stack trace, I'm calling into my other code here, right? Like the thing that's actually creating the stack trace object is the destructor of entry builder. So that's in the trace. And then that is doing some std optional in place, which does this thing here, which does this thing here. And we go down to here. Now I'm constructing my stack trace wrapper. And then that finally calls the load here function from backwards stack trace. So it's cool we get a stack trace, but there's a little chaff in here with the wheat. Now I think we could do something about that. So using IntelliSense as documentation, as I tend to do, we can see what our interface on the trace is. And there's some interesting stuff here. Now one thing that looks interesting to me is skip n firsts. So how could we possibly use this? I mean, we saw that we were I think maybe 6 deeper than we wanted to be. So like if I try to skip 5, is that going to work? And do we call it before we load or do we call it after? I don't know, but let's check it out. Let's just run it. It's easier to ask forgiveness and blah, 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 blah. Okay, so now we see that we only have one level of chaff. So we've eliminated a lot of chaff. So I think it was 6. So if we now skip 6 after loading the stack trace context, now our stack trace has a lot less garbage in it. And it just says, yeah, here is where you threw that garbage. And here is a bunch of, stuff that is outside of your code. So we can't print any code, but we can at least tell you what the name of the module is and the line in that module. And there you go. Bob is, that's Bob. That's Bob. That's Bob right there. And for shits and giggles, I'll put a log call inside of a function that's called from main, and we'll run that. And now we see here chilog.error, oops, from function f. And then one up the stack, we see that's being called from here. This caret is it's a little off. It's like the next line from the line that made the call, but it doesn't matter. So now we have our entry builder capturing stack traces. We're hard coding in the level at which we capture stack traces, and in the future we'll want to be able to configure that perhaps by using a policy, but that's there's some tricky issues with that. So we'll worry about that in the future sometime maybe. Now the last thing we're going to do is a little bit of a nitpick here, but what I'd like to be able to do is I'd like to be able to double click on the location in the stack trace and automatically jump to that in the source code. But you see this format here isn't going to allow for that. So, and we could create our own printer to print things the way we like and use that. And that's probably the main way to do this, but I'm lazy. I don't want to do that. So I'm just going to edit the printer that they have in backward.hpp. So we can see here they have an indent, they print source. So probably outside of this function, it's outputting this trace index or whatever, hashtag 1, 2, 3, 4. So that's being done outside of here. Then they call this function, they print source, escape quotes, file name, that's in here. So we want this file name to be on its own line and not prefixed with this number. So I'm going to try something like this. We immediately do new line and then indent, and then we do the file name. And yeah, so this might do the job for us. Let's run again. So now you see we get a little bit of a stagger here on these lines, which is, you know, it is what it is. But more importantly, because this is on its own line, if I double click, I go to the place where it's pointing in here. Double click here, and I go here. Which is pretty close to where we want to be, right? Off by 1. No problems there, right? Anyways, but yeah, that is, I think that's what we want right now for a stack trace. There's improvements to be made, obviously, but this is a fine start. And yeah. Also, if you guys know, well, I'll throw it out to you guys. If you guys know of a way to fix this off by 1 shenanigans so that instead of pointing here, it points here, for example, let me know, because I'd love to know that. It's not a big deal, but it would be nice to improve that. Anyways, thanks for watching. Hope you enjoyed this video. If you did, please click the like button. Helps a lot. And I will see you again with some more C++ game engine infrastructure.